Hey, good morning. So I've been working on a little project called Commons Host, and I'd love to share about that. My name is Sebastian, and you can find me on Twitter, GitHub, GitLab, anything. I live in Singapore, and I like a lot of different things that I try to focus all my time on. And so a couple of years ago, I started experimenting with protocols called Speedy, which then became HTTP2. The following year, I ended up kind of contributing a little bit to HTTP2 and Node. And this year, I've been working on this CDN, which is 100% open source. And so far, in the last 6 months, since sort of officially launching it, there's been about 20 POPs. That means points of presence, servers around the world, edge servers. Each of these servers, which is kind of like the different things, not just is it open source, it's also owned by somebody who lives in these places, or somebody who donated, or has the ability to host them in some places, like some remote office or their homes. It's running on really, really tiny servers like these here. These are Odroid servers. They're off-the-shelf, kind of like a Raspberry Pi on steroids. Very cheap, very efficient. Like there's no fan or nothing. It just contains a SSD and like a little phone CPU. I'll talk more about that later. So what can you do with this service? There's a bunch of tooling that I built for it. This is how you deploy. NPX is part of NPM, which is part of Node. So if you have Node, you have NPX. You can just deploy a static site to this network of servers, and it'll be cached globally and be really fast. You can follow, if you run a command, I'm not going to read like the whole README here basically, but you get some nice little command line interface to deploy your site. You can do custom domains, all these kind of things that we're kind of sort of used to having available in these similar tools. Set up your DNS and point your domain there, you get a Let's Encrypt certificate. One cool thing that I focused on a lot was server push. That came from my experimenting with the protocols. Server push lets you eliminate round trips, which is a big deal if you're in a place with a lot of latency, like if you're far away like me from where your users might be. You want to eliminate round trips by just stuffing the connection full of data that the user will end up needing. So there's a tool here. You can run this on any static site that you have. It will automatically generate a manifest of all of the HTML, CSS, and JavaScript dependencies. So it'll figure out all your imports all over the place. So any static site generator will eventually output one of those 3 standards file formats, and it'll just parse them all and build a little JSON manifest that the CDN will then use to push all these assets automatically. So like I said, there's documentation for it. That's the tooling. I want to talk about more like, why am I even doing this, right? You might be wondering, like, there's so many other ways to host sites. What am I adding to that? But 10 years ago, I started out in Singapore, and my experience there, living there, sort of on the internet side of things, was kind of struggling. Like, if everything felt really slow, coming from comparing with like Europe or the US. DSL was maybe the same bandwidth, but you had a lot of latency. A lot of that was because there's no local data centers or internet exchanges, so you end up doing very long round trips. You're going to a web server in the United States or in Europe, you're waiting a quarter second on each round trip. Nowadays, if you do TLS handshakes, that's like 2, 3, 4 times, and it takes like 2 seconds to even start your connection. It's just a very uncomfortable experience. So today, things have gotten a little bit better, a little bit more modern. One of the good things about living in Singapore today is you get gigabit fiber at home for a tiny fraction of the median income for most families. This is available in like 95+% of all homes. You can go up to 10 gig if you really find the need, but then you're going to struggle connecting devices to that at any speed. We've also got a ridiculous amount of internet exchanges. This is a small city, keep in mind. It's a small little island. There isn't like a big country behind it. It's just one small city. A lot of exchanges, a lot of data centers, a lot of ISPs, networks, a lot of CDNs also operate there. So I typically find myself from home like 1 or 2 milliseconds away from every CDN that I typically use. That means you can do multiple round trips to your server within a single frame update of your screen. It's interesting use cases there. Singapore itself, like I said, is really too small to consider having an impact. So what I wanted to design for is something that has a larger impact on the world. Luckily, Singapore is sort of almost right in the middle of this little circle, which has more people inside of it than outside of it. You might have seen this before. Similar sort of breakdown of how does the world actually work, where do people live, can I sort of see a show of hands, like who spends most of the last 1 year in the first part, like the Americas? Anybody? Okay, so maybe it's NodeConf EU, so maybe most people here in Europe and Africa. Anyone? Yeah, there we go. Okay. But most people in the world actually live in the other part, which is most of Middle East, Central Asia, and Asia Pacific. So the good thing is that this fiber, turns out it's pretty much available everywhere across Asia Pacific. You have something like a disproportionately large amount of fiber subscribers in Asia Pacific versus Europe and Africa, America, which are traditionally more mature, developed countries. A lot of that comes from the recent development explosion across Asia. If you visit any Asian cities, you'll see scenes like this. It's just new developments, high-rises, very dense environments. And what happens when you build new buildings? You put in current era networking infrastructure, which means you just go get fiber. You don't need to go get DSL or cable these days. You also don't have incumbents, with existing investments that they have to protect. So you just go and build a fiber ISP. So it's pretty much available in almost every city. Not saying that everyone is using it. You end up with availability versus adoption being very, very different. So on the sadder side, data centers and internet exchanges are still kind of difficult to access outside of a couple of major areas in Asia Pacific. And that looks like this. So there's this submarine cable maps that you've probably seen before. The top boxes show some of the major capital cities, like Bangkok, Ho Chi Minh City, Jakarta, Manila, huge populations, backed by countries that are also like 100 million plus each. Yet most of the actual glass in the water, the fiber connecting all these countries to the rest of the world, happens to connect in basically 3 points across Asia Pacific, which is Singapore, Hong Kong, and Tokyo, or the larger Tokyo area. So there's a lot of fiber in each of these countries domestically, but connecting between them is still a huge problem. And so they all get sort of bottlenecked through these 3 major internet exchange centers. That's because the internet is a concept, not a thing. The internet doesn't look like this kind of map. This is nonsense. There is not a cable from every ISP to every other ISP in the world. The real world is very different, much more uneven. It works through peering. Networks connect to other networks. That's literally what the internet means, interconnected networks. And this is negotiated by ISPs directly. And they end up coming to terms like, do I have to pay you for this? Can we do like a free exchange? Can we just plug into your switch and exchange any kind of traffic that we want? If your network is, say, a small office building and you have a couple of closets full of servers versus you have a network that's tens of thousands of kilometers of fiber around the world, you're going to find different terms for that peering, of course. The purpose of it is really to lower cost, and then a nice side effect is that you just have way better performance over latency and bandwidth. This is, of course, if you're a technical person, you might see it the other way around. But eventually, peering sort of arises from the world being uneven and lumpy. You see a lot of the maps that we looked at earlier explained by the fact that the economics force people to just all connect in a single place rather than all connect to each other. Because if you're just pulling one cable to an internet exchange, it's much cheaper than pulling like N cables to all of your peers. If you all connect to that one internet exchange, you end up with this concentration and this sort of star-shaped pattern. You also have reasons why it's hard to actually deploy infrastructure in a lot of places around the world, maybe particularly outside of Europe and the United States, because of regulatory constraints. And a lot of times you have sort of older companies that have been around, built out the infrastructure initially, and are only now starting to open up. So as a new entry into that market, it might be very, very difficult for regulatory reasons. I recently came across this when I deployed a new POP, one of these boxes. Well, actually, I should say the person who purchased it and put it at their house in Thailand, a small city called Udon Thani in the north of Thailand. I was tracing how does traffic go from that location to an ISP in Singapore and another ISP in Singapore. And for one, for one ISP, it was going basically from Udon Thani, this town, to Bangkok, which is the capital of Thailand, straight to Singapore. And you would get something like 40 milliseconds round trip. But for the other ISP in Singapore, the same distance on the map, it ended up going via a pier in San Jose, California, which is interesting because you're doing like 23,000 kilometers extra or something. And it's actually going from that town in Thailand to Bangkok to Singapore, then to California, then back to Singapore to finally reach this ISP. So I was like, that's interesting. So you end up with a lot of ISPs not being that well connected to each other and having to fall back on some of these internet exchanges. So there's maybe, if you look at probably like the top 30-ish internet exchanges, they'll carry the vast majority of traffic, but that doesn't mean it's always efficient. It might be better for ISPs to connect directly to each other. And right, so I've been playing with that idea of, originally you put like a cache at every internet exchange, so you can serve as many ISPs as you want. But if that's not always super efficient, why don't we just put a cache at every single ISP? Now the problem is there's like orders of magnitude more of those. So that would scale your cost by orders of magnitude unless you brought the cost of the cache down, the hardware cost, the networking cost, which is why this is a tiny little server, a tiny little cache, and not a rack of servers or a data center of servers. So if you look at how many would we actually need to do this, there's like 500-ish cities or urban agglomerations or urban areas around the world with over 1 million people. There's over 1,000 with over 500,000 people. The majority of these, the majority of the world lives in cities of over 500,000 people. The majority of those is in Asia, et cetera, et cetera. You see where I'm going. If you look at how many ISPs would there then actually be, the upper bound would probably be something around this number, 63,000. And that's based on how many networks are announcing routes to each other. There's probably in reality a lower number than this, because this is also including a lot of like smaller networks or duplicates of ASNs that like a single network might use different ASNs for administrative legacy reasons. So that's probably like an upper bound. How do we get to that? Well, I'm trying to start really small because I just started this project by myself, so I don't have a massive amount of funding or anything like that. If I build this thing based on like under $200 budget, I could probably build something that saturates most people's 1 gigabit fiber connection at home or at their offices. And I'm focusing on just serving only static sites, because then I don't need a lot of CPU or RAM or massive amounts of storage. I can just put a SSD hard drive together, and that'll be more than enough to saturate 1 gigabit. Right now, in the last couple of months, it's probably a little bit less than 6 months now, but we've managed to deploy about 20 locations. That's all thanks to friends helping out, basically finding out about this and going, yeah, sure, I'll put one in some interesting location. Also spent a lot of effort to automate this so we can actually deploy a new server in literally minutes. I've had cases where an ISP in some country wanted to test out how would this save bandwidth for them or make sites more efficient for them, and it took 30 minutes from doing a call with them and saying, okay, let's deploy it, give me a VM and we'll spin it up. The whole effort is actually based on these 3 major commoditized technologies. One is JavaScript, which obviously the crowd here understands. This fiber to the home thing, which I explained, is really of shocking scale across Asia. And then ARM, which is what happens with your mobile phone. So JavaScript, Node.js is amazing at exposing really fast, low-level libraries written in C or C++, giving a really beautiful API on top of that and making it super amazing for developers to build on. And with NPM, we don't even have to build on it because we can just use other people's stuff, which is awesome. A lot of these people here, I owe a lot of gratitude to. Then second, fiber to the home. Well, to me, like these 2 pictures here, on the left-hand side, that's a typical server rack. On the right-hand side, that's where I lived last year. And, well, both of these have little boxes that might be scaled, but all have the same connectivity. Have air conditioning, have power, have all of these nice things. And if you look at most of Asia, you see a lot of housing like that. So if I can deploy servers across this, I can actually bypass all of these internet exchanges and get straight onto the ISP with servers which is equivalent to doing peering without all the tedious negotiating and all that overhead. And lastly, ARM. You might have seen, recently comparisons like this where people look at Intel servers versus ARM servers and see, it's so much more efficient in terms of energy consumption. To me, there's a little bit of deja vu here going on. I remember about 20 years ago, this little thing came out. It was a very innovative service. You might know about it. I think one of the most innovative things that they did was not the search page, which is great, but the actual fact that they used commodity hardware to deploy everything on. The big idea for Google was actually, to me, that they focused on getting the best performance per dollar for their hardware, rather than getting the world's biggest server to run it on. They ditched the whole idea of enterprise server hardware and went for Intel-based servers that were then the commodity. But I think today, ARM is the commodity, and Intel has sort of become, David versus Goliath thing. Eventually, they've become the big, powerful server hardware. And ARM is actually now the new commodity because we all carry it in our pockets. The best performance per dollar of ARM is probably going to be, well, this slide is now a month outdated, I guess, last year's phones. So they're no longer available in the market, but you can pick them up from all these Chinese shops that sell vast numbers of them. In fact, if you look around, you'll see that, like in Shenzhen, you can walk into a shop with a stack of cash and get an insane amount of last year or previous gen CPUs for very cheap. You'll see the trends of Intel versus ARM going like servers and desktops, which is mostly Intel, it's kind of like going up a little bit or stagnant or slipping a little bit, versus mobile, which is completely, that's basically tapering off in the upcoming years predicted because there's only so many people in the world that you can sell phones to. In absolute numbers, it's totally ridiculous. There's like over 100 times more ARM CPUs being sold than server CPUs, and sure, there may be like 100 more, they're much more powerful, but that's where a lot of the investment is going, is based on absolute volume. That's why there's over 100 billion ARM chips being sold, have been shipped. Most of your phones are running them. So this is basically a version of your phone in a box. This is like a phone from a couple of years ago with an SSD and a network port. So the reason for them being so pervasive is that there's a lot of companies just making the same designs or spin-offs or variations of the same designs. So you have like a huge market by itself. And some of the ARM chips used to be very, very low functionality-wise, very simple designs, but nowadays you have like hardware-accelerated TLS, which is amazing because all HTTP2 traffic for your browser is going to be encrypted, so it's going to be fast now, which brings me back to the server. That's what I'm using. And if my goal is to create the largest CDN that could be closest to as many people in the world as possible, and I want to do this really quickly on basically no budget, I have to consider how to grow this network. And this is where recently I've been experimenting with a couple of things. So the core idea behind this is to actually build a CDN that's not just one company, but where the infrastructure itself is owned by people around the world. I think that would allow a more depth and resolution in building out infrastructure for the internet. I think a single company is going to be constrained by how much they can manage, how much they can go into countries and figure out the regulatory environment and the business environment and get investment to build fiber, to build servers. I don't see myself doing that. I think other people could do that better, and if I can provide software that they can use, we can build the world's craziest CDN. So first thing is, okay, maybe you can make it even cheaper. What if I just run it on spare servers, give me a VM, and we can deploy on it? Or we can scale it down to like Raspberry Pi, which is even cheaper than this. Like $200 budget becomes like $25 budget or $35 budget. That might help as well. Others could be, like this is essentially a way for people to run their own CDN, so they can run the software, the stack, which is 100% open source, on their own hardware. But I'm not sure that's really something that people are too excited about, like managing servers around the world themselves. It's kind of like the opposite of what we've been doing with cloud. So you could run it on cloud, of course. And then another idea was to build sort of a marketplace where, like I said, I don't want to be owning every single server. I don't feel like that really scales far enough as what we need. So there could be a way for people to avoid the obvious tragedy of the commons, which would be that the service is one successful site away from failure, where somebody put up like a huge video streaming site or something, and it would just consume all bandwidth and everyone would be unhappy. What if this could become a infrastructure marketplace where people who want to publish lots of content could come and say, oh, you've got servers out in, random place in Asia or Africa or South America or Europe or America. You could do a sort of a revenue share with them. So this is something I've been thinking about. I haven't really worked on it. It's a lot of work. And another thing that I have been doing a lot lately is DNS over HTTPS. Because it turns out that these servers, if you put them in large numbers, you just get really low latency to a lot of people. DNS over HTTPS is a new way to secure DNS. The threat coming from ISPs and maybe coercive governments that would like to manipulate or record or prevent your internet traffic. The way it works is really quite simple. The spec is incredibly simple to implement. You just establish a HTTP2 connection, and then all your DNS traffic just goes into a post request, and you get a response back, which is just the binary payload of a traditional DNS lookup. So it's really easy to implement. It's a very simple spec. It's very, very, very nice. It also came out in it started about, I think it took about a year and a half to go from just random idea to final spec, which was published a few weeks ago. The benefit that the Commons host network might have is that you have a lot of servers. You just get, lower latency for the median user by default, just by physical proximity. Being on the ISP is going to be faster than being at an internet exchange, and being on more ISPs is going to be faster than being far away from people, obviously. The other thing is you want to make this a public service so that you get more users to use your individual edge server, because then the cache is constantly being refreshed with current DNS results, which means that the next person who goes and hits that same domain is going to instantly get a response instead of doing a recursive lookup. So with a friend, I've been working on a couple of projects called Play-Doh and Donut. Here's my friend. He's probably one of the people that got me into Node maybe 7 or 8 years ago, and he's stepped out of it, but he's an amazing programmer, and he's sort of overnight implemented a DOE service, a DOE proxy, as a way of getting back into Node, which I thought was pretty sweet. It's based on DNS Packet by Matthias. It's an amazing library that enabled the whole thing to actually work. So what Play-Doh does is it proxies DOE requests to a local DNS resolver. So we've sideloaded a DNS resolver on every single edge server, and so when you make a DOE request, what you're doing is you're connecting to your local edge server, and that's then performing the lookups or getting them from cache to make it really fast. There's zero logging, there's zero censorship, none of that. Like the way that these things work, you couldn't even afford to log because there's a performance overhead and a cost overhead. You can try this today with Firefox, but if you don't use Firefox, you might want to look at this project. This is the next thing that we're working on, which is called Donut. It's a DNS to DNS over HTTPS, or rather HTTP2. The way this works is this makes DOE available and provides all the benefits of DOE to any application on your system or any device on your network. The way it works is you run a sort of a background service, and this is a little UI for it that we're working on, that would open a local port 53 regular DNS server that you can use in your network settings to configure to point your devices for the regular DNS to this local host proxy, and it'll then make it the DOE lookups on the back. So it'll open up the HTTP connections and do all the DNS lookups over DOE to Commons host or any other service that you provide that you choose. We're playing with some interesting ideas. We could make it really much harder for people to track even DOE, because with DOE, it's no longer your ISP is sort of a threat. Now it's your DOE provider, which could be some company that you may not trust, or maybe you trust a company, but the company itself is under duress or under threat by other entities, like a nation-state actor, adversary. So there's a lot of things that we can do, like slice your requests, shard them across different providers, spoof random requests to the top 20,000 Alexa domains or something at random intervals, so you don't really know what this person is actually looking up. So you can do lots of stuff to enhance privacy. Once you bring this into Node.js, because there's just so much more programmatic control over it. So this is a little project that we've been working on. If you're interested, let me know. And what this also could enable is using some of the new features with HTTP2, like alternative services that James Snell talked about, and the latest, one of the latest features that was added to Node is the ping events, the ping frames, which enable the Go client to sort of sample multiple Go servers around the world and find the fastest one to do their lookups. That could enable us to build a second tier of the CDN, which would be servers that don't have storage. It would be pure Raspberry Pi type of devices, so you all have something like that in your drawer collecting dust, because after the blinking LEDs, it's not that fun anymore. So you could run a Go server on there and help people in your town on your ISP to build a large Go network that is public and uncensored for everyone in the world. So I need some help with this. Please check it out, use it, publish a site on it, take a look at any features, let me know if something breaks. If you want to host something, get in touch with me. I'll be out there. I also need people to, fund some of the hardware. I'm really generous, really grateful for people who've done that so far. And otherwise, just tell some people about this. Please send me a tweet or something, and I'll be out there with stickers and T-shirts and things if you're interested to talk. Thank you.